Hello students, welcome for our chemistry lesson. This is from fourth session and we are going to cover chemistry. Our first lesson, electrochemistry is the topic and the subtopic is redox reactions. I am Mr. Moses. Welcome. I hope you will enjoy the topic. Now, the objective of our lesson today is one, you should be able to define the term electrochemistry. Then two, you should be able to define reduction processes and oxidation processes based on three things: based on transfer of oxygen, transfer of hydrogen, and transfer of electrons, and finally change in oxidation states. And again, the third objective that we must achieve is to define, to identify and to define reducing and oxidizing agents. So let us come to our main topic. We are going to deal with a branch of chemistry. This is a branch of chemistry that deals with electrochemistry. So in electrochemistry, you must have some knowledge on one. You must have some knowledge on one. You must have some knowledge on the effects. The effects of electric currents on substances. The effect of electric current on substances. You must have some knowledge also on computation. Computation for combines oxygen. Computation for combined oxygen. And again, you must have some basic knowledge on the topic of mole. Then make sure you are able to write half equations. So we are going to base our these four areas will help you to understand this topic easily. Ready? Now, move on. So, what is electrochemistry? Electrochemistry is the study of the relationship between electrical energy and chemical reactions. So, in this branch of chemistry, we are going to deal with two things. We are going to deal with chemical reactions vis-a-vis electrical energy. Now, how? One, we have chemical reactions. We have reactions that give electrical energy. Like, for example, in Form 2, we dealt with electrolytic cells. And if you can recall, we had a setup like this. We had a setup of this nature in Form 2. For example, let us say electrolysis of molten copper 2 chloride. This is our source of electric current. So, in this example, we have a source of electric current. Which is the battery. This battery gives out electric current. Then when you close the switch, this one is the positive terminal, the negative terminal. So this one will become positively charged. because it is connected to the positive terminal of the battery. This one will become negatively charged. So if you have copper 2 ions, they will migrate to the cathode. If you have chloride ions, they will migrate to the anode. And therefore at the anode, you will have chloride ions getting discharged by using electrons to give chlorine gas. So there is a reaction already producing chlorine gas. And what has resulted, or what has brought about that chemical reaction? It is the electrical energy from the dry cell here. Then on this side again, when the circuit is closed, the copper 2 ions will gain electrons to form copper. So what has brought that chemical reaction? What has brought it is actually the flow of electric current. So one, we are going to look at the production of electric current, electrical energy, or we are going to look at cases where electrical energy results in chemical reactions. Electrical energy results in chemical reactions, electrolytic cells. And some of them form 2. Then again, what else? What else are we going to learn in this topic? We are going to look at cases where, the second case is where we have chemical reactions giving us electrical energy, like in a dry cell. The battery that you use at home, inside that dry cell, there are chemicals, and those chemicals are reacting to give you electrical energy. You can use that energy to power your radio, you can use that energy to power your spotlight, you can use that energy even to power your watches, to power your small gadgets. So that's what we're going to look at here. The relationship between chemical reactions and electrical energy Now, moving on. So, for the sake of our discussion and simplifying this topic, which is a very simple topic, we are going to concentrate on 3 major areas. One, so this branch of chemistry will divide it into reduction and oxidation processes, what we call redox reactions. 2, electrochemical or voltaic cell. And 3, we'll look at electrolysis. So we are going to study this topic in 3 sections. Redox reaction, that is reduction and oxidation reactions, and then chemical cell and electrolytic cell. We move on. The first thing that we are going to do now is to look at reduction and oxidation reactions, what we call redox reactions. Now, redox reaction can be defined based on transfer of oxygen. So when we talk of redox reactions, it can be defined based on oxygen transfer. 2, defined based on hydrogen transfer. You can also define redox reaction based on electron transfer of electrons. And finally, based on change in oxidation state. So, for our purpose today, we are going to concentrate on 1. Then, next time in our second lesson, we'll concentrate on the second one. So we are going to look at it in terms of oxygen transfer. So if you look at my screen here, I've summarized the meaning, and these are things that you learned in Form 1, even in Form 2. So in terms of oxygen transfer, reduction is the removal of oxygen from a substance. Removal of oxygen. And then oxidation is adding addition of oxygen to a substance. Redox reaction is the simultaneous addition and removal of oxygen, meaning a reaction where there is both removal and addition of oxygen. Then when we come to reducing agents, this is a substance that undergoes oxidation, meaning an oxidizing agent oxidizes a reducing agent. So the reducing agent is the one which is oxidized, and therefore by being oxidized means it gains oxygen. Oxidizing agent gains oxygen. When we come, the reducing agent gains oxygen. When we come to the oxidizing agent, it is the substance that donates oxygen. To oxidize, to bring about oxidation, to add oxygen to a substance. To understand the concept, for us to understand that concept, like here when hydrogen is passed through heated copper to oxide, it is oxidized to copper metal as the equation below. So it is oxidized to copper metal as the equation shown below. So let me explain that. So now we are talking about redox reaction. So first, we are saying if you take copper to oxide, you heat, then you pass hydrogen over the hot copper to oxide, you remain with copper and you form water, liquid, solid, gas, solid. So what happens? Copper to oxide is changing to copper. Hydrogen is being converted to water. For copper 2 to change to copper, we have removed. What have we removed? We have removed oxygen. Removal of oxygen from a substance is reduction. So copper 2 oxide is undergoing reduction. Hydrogen has changed to water. What has happened to hydrogen? It has gained oxygen. We have added oxygen to hydrogen to form water. So in that case, we are oxidizing hydrogen to water. So hydrogen is undergoing oxidation. So this is a redox reaction because there is both reduction and oxidation taking place at the same time. Now we are supposed to identify oxidizing agents. Now in our case, the oxidizing agent here is the substance that donates oxygen. It loses oxygen. It gives out oxygen. What is giving out oxygen? It must be having oxygen. So the substance that is giving out oxygen is copper 2 oxide, carrying that oxygen and giving it to hydrogen. So this is our oxidizing agent. Why? Because it donates oxygen to hydrogen. Then we should also be able to identify reducing agents. So how do we identify a reducing agent? It is the substance that accepts oxygen. It gains oxygen. So what is gaining oxygen here is hydrogen from water. So our reducing agent is hydrogen. And then why? because it gains oxygen. It gains all oxygen, or it accepts oxygen. So that is the redox reactions based on transfer of oxygen. Based on transfer of oxygen. So we have managed to define electrochemistry. We have managed to look at redox reaction based on transfer of oxygen. Now you can identify reducing an oxidizing agent when given a redox reaction, and at the same time you can also identify the oxidation process and reduction process based on oxygen transfer. So in our second class, we are going to look at the definition of redox reaction based on transfer of hydrogen. Thank you for watching and be blessed.
Okay.